Hi, everyone. So here is lesson 3. So this is one or more x's to one y. And it always says right here what we're going to learn. So defining functional relationships. I should hope that all your relationships are functional. All right. And so if you look right here, our learning targets are these. Oh, I'm going to go blue today. I'm feeling a little blue. All right. So describe a learning function. Describe a functional relationship in terms of a rule which assigns to each input exactly one output. Okay. And also, and if you don't know what some of those terms mean, we're going to learn about that, like the input, output, functional, not the kind of functional that you're thinking of. Well, it's kind of the same, but yes, functional. And then also determine whether a relation represented as mapping. So if you don't know mapping, we're going to learn that today. A set of ordered pairs, table, sequence, graph, equation, or context is a function. So we're going to determine whether something is a function or not a function. More specifically, whether a relation is a function or not a function. If you don't know what a relation is, then we're going to talk about that too. All right, so we went down here. We said this was our do now. So if you have not already, so if you did not do this, you want to find out what the rule is. If you look, so our x is like our input, right? So if I give you a -6, what do you get out of it? It's going to be a -12, right? So you have to figure out what the rule is. What did I do to -6 to get a -12? And so some of you guys may be like, well, you multiplied by 2. And we're like, okay, let's see. And then this rule has to be the same for all of them, right? So we're like, okay, -3 times 2. Does that give me, oh wait, that gives me a 0. So then we know, oh, the rule is not times 2 because that would work. The rule has to work for everything in the table. And so that does not work. So we're like, oh, shoot. Okay, that's not going to be it. So what we're going to do is we're going to be like, okay, so we try different things. We like, okay, 3 times something, right? We got the plus 12, right? The reason why we got plus 12 is because of this guy right here. So if you notice right here, this is when we put in a 0, we get a 12, which means I know that I'm going to be adding 12 for some reason, right? Oh, for not, but that I'm going to be adding 12. So I said, okay, so it's going to be something times 0 plus 12, and that's going to give me this 12. So I said, okay, so let's try 3. I like trying bigger numbers because I think for me, makes more sense. So 3 times what will give me, plus 12 will give me a 24. So we tried different numbers and we settled on 4, right? So I think we said 2 first, and then we tried 3 times 2 plus 12. That didn't give us a 24. And somebody said 8. So 3 times 4 is 24, but we had to add 12. So that we're like, okay, it's not that. We're like, oh, what about times 4, right? So 3 times 4 is 12 plus 12. Okay, that's 24. Now we got to check. Does it work for everything else? So we know it works for 0, right? Because 0 times 4 is 0. And then add 12. That's 12. Okay, good. Now what about -3? So -3 times 4 is -12. And if we add the 12, then that gives us what? 0. What? Yes. Okay, so we got that. So -6 times 4, which is -24 plus 12, that's going to give us 12, right? Or I should say -12, because that's a -24, right? So that would be -12. So yes, we got the answer. So we said our function was y is equal to, so this y, this is the y values, is equal to 4 times x. So 4 times whatever the x value is, right? And plus 12, right? And somebody had noticed that, oh, the 0, 12, that's a y-intercept. Coincidence? We'll talk about that later. And so we did the same thing here for letter B. And we're like, oh, you just, somebody had said, oh, we just multiply by -2, right? So we try that. So 0 times -2 is -2. Okay, 5 times -2 is -10. Okay, well, now I'm a little more confident with this, right? So let's try the other ones. -1 times -2 is 2. Okay, that works. So, and -10 times -2 is +20. So happy days, right? So our function is y is equal to a -2x. Okay, so any x that you give me, I'm going to multiply that by -2, and then that will be my output, which is my y. Okay, and then we did the same thing here. We're like, okay, so I'm thinking we're going to multiply this by -1, right? So we did this down here. So we're like something times x -1, right? And the way that we got the -1 was because of this guy right here. Right, but here's the problem. Okay, so we didn't get to the problem yet. So we go -1 times -10 is 10, and then -1 is 9. Okay, that totally works. And then -2, if we put a -2 in there, -2 times -1, right? -1. So -2 times -1 is going to be 2, minus 1 is 1. Okay, that works. And then we know the 0, but it did not work for 5, right? So 5 times negative 1 is, so if we go, let's do it right here. So 5, I should say negative 1 times 5, and then minus 1. So that would not give us a 4. That actually gives us a negative 6. We're like, what is going on? So I checked, and actually it is supposed to be 4, which means that our solution here is not correct. Okay, that's not what it is. So we're like, okay, so there's got to be something. We know it's subtract 1, right? There's got to be something else. And so I was thinking about this. And we're like, okay, we know it's subtract 1. So, but we know it has to be like a positive, right? So how do we make all these numbers positive? Do you guys remember? I don't know if you know, but it is going to be the absolute value, right? Because if I go the absolute value of 10 or negative 10, so let me just write this over here. It's in blue. So so the absolute, so we're going to go absolute value of negative 10 minus 1. What is the absolute value of negative 10? If you don't know what the absolute value means, that's just how far is negative 10 from 0, right? If here is negative 10 and here's 0, how far is that? Well, it's 10 away, right? That's why it's negative 10. So it's 10 away. It's just on the negative side, right? So that's why we say, and this absolute value makes that, we're just talking about distance. How far is it? So this is, it's 10 away. So it's 10 minus 1, which means that it's 9. So do you see how it does the same thing? So then we're going to do our trouble one. I thought that was absolute value. I looked at it weird. So we're going to do our absolute value of 5 minus 1, right? What is the absolute value of 5? And then you ask yourself, well, how far is 5 from 0? What's 5 away? So 5 minus 1, which is 4. Do you see? Now we get it. So this is our function. Happy days. All right, we'll just do this last one because we didn't have time during class time. But I noticed right here we have the 0, 2. We know, so we're going to be definitely adding 2, right? So this is going to be some number. Here's our, we'll go minus or plus 2, right? And this is going to equal something. And then so we know that it's going to be, here's our x right here, but we don't know what we're going to either multiply or divide. I don't know. We'll find out. But usually it's multiply. And I see these numbers getting better, so I'm really thinking multiply, right? So let's try this big number here. So if I put in a 20, ooh, maybe it's not, because these numbers are getting smaller. So if I put in a 20, so 20 in for x, what I'm going to multiply by, and then add 2 to get 12, right? Well, I'm like, well, I know I want to get this to be smaller. So maybe I divide, right? Divide by 2. So, or I could say multiply by half, right? So multiply by half. So 20, half of 20 is what? 10. And then 10 plus 2. Okay, that's 12. So let's see if this works. Okay, so I'm thinking right here, maybe it's 1/2. Okay, so we're going to go with 5. So here's my 1/2 times 5 plus 2. And you're like, Ms. Lee, it's fractions. I can't do fractions. Sure you can. So what's half of 5? If you and your sister or brother or whoever, you guys have to split up $5, how much do each of you get? $2.50, right? 2.5. So this is going to be 2.5 plus 2, which is equal to 4.5. Is that what we're supposed to get? What? Yeah, exactly, right? Just like this. Okay, and we'll try that one more time with the 4. So we're going to try 4. So 1/2 times 4 plus 2. So what's half of 4? Well, half of 4 is 2. 2 plus 2 is equal to 4. Yes, so we got this. So this is going to be 1/2 x plus 2. And that's going to give us the y. Another way you could have done that is just go x divided by 2 plus 2. And that equals to y. It's the same thing. This means no. Okay. All right. So there's that. And then we went on to this new stuff here. So we have, if you have your highlighter and you have your book, and if you don't, then make sure you pick it up. Here's mapping, right? So mapping represents 2 sets of objects or items. Okay. And so we normally have the input side and we have the output side. And the way we figure out which one's which is by the arrows. So the input always has, we usually put it on the left-hand side, and then we put the output on the right-hand side, and then we put an arrow saying the input, it goes in as a 1 and it comes out as a 7, right? It goes in as food and comes out as, well, I'm not going to tell you. You can figure out that one, right? But you should be doing that at least 1 time a day. Okay, that is common, right? And that is safe. and that is healthy. All right, so here, and a set. And what is a set? It says a set is a collection of numbers, geometric figures, letters, or other objects that have some characteristic in common, right? So for us, we're going to be doing sets with numbers, okay? So because we're algebra, and and so the way we denote sets is with these braces right here. Do you see those little, yeah, these things that people can't do that I like doing? So these are called braces, not the kind that you have on your teeth, although they kind of look like that, right? Or they're trying to keep your teeth from looking like that. So if you notice, this is right next to your P, right? You got those little braces. You shift, and then the thing next to your P, underneath that is like your square bracket. I talked about that in Algebra 1. We won't talk about that here. I mean, in Algebra 2. My bad. I am in Algebra 1 right now. All right, so now input, output. And I'm going to just erase this guys here because it gets a little bit confusing. All right, and if you notice, right, input. So if we put in a 1, what do we get out? We get out a 7, right? And so the way we would write that as an ordered pair, remember, ordered pairs, you know, like things that we could plot as points, right, is we're going to put our input first, so that's our 1, and then our output second, which is our 7. In other words, that means our input is our x values, and our output is our y values, okay? So that's what we're going to do. And then so again, 2 goes to 1, that's why I got 2, 1. And then 3 goes to 5, 3, 5. And then 4 goes to 3, so 4, 3. And those are all the points in that relation, okay? And so we end them with braces. All right, and so we can do the same thing for number for letter B, right? And so I'm gonna put this, I'm gonna give myself a little bit of room here. And I'm gonna delete some of these guys. And put this in blue, okay guys? So we're gonna do the same thing. So if you wanna pause right now and then do this too, follow along. Then yeah, that would be great. It would be good practice for you. Okay, I'm assuming that you've now unpaused it because you've done letter B, right? And so again, I like to start from the top. So 1 to 1. So this is gonna be 1, comma 1. Please do not forget your parentheses because that indicates that it's an ordered pair. You don't have those parentheses. It's just two numbers next to each other, right? And then 2 also goes to 1. So that's fine. They could go to the same number. And then 3 goes to 5. So we've got 3 going to 5. Contact's dry. And then we got 4 going to 3, so it's 4, 3. It's like a puzzle, like a match. So 5 going to 7. So that's 5, 7. And end that with the braces. Okay? So that's what you should have gotten. And then we did the same thing for number C, so letter C. So, and if you notice right here, 2 goes to 3 as well as to 5. So it goes to 2 different numbers. So we actually have 2 different points. Okay, so we have 1 at 2, 3. It should be next to it, but I kind of forgot to leave space. And so I put it here at the end. Okay, but normally it should be over here. Honestly, it doesn't matter, but I like to put them in order because I'm like an order kind of person, right? So 2, 3, and then 2, 5. And then we have 3, 5, 4, 7, and then 5, 7. So we have all those. So we have, so the number of arrows we have tells us how many points we should have. So if you look at, where are you? There you are. So you have 1, 2, 3, 4, 5, 6 arrows. So we have 1, 2, 3, 4, 5, 6 points. Fair? All right. So we're going to do the same thing for D. I'm going to write D over here. So if you want to pause right now and then try it out, see if you can do it. All right, good. Good job. You paused or you didn't. You're like, I don't care. I'm going to just press play. Right. Remember, 2 goes to 7. So we got 2, 7. And then 2 also goes to 20. So we're going to have 2, 20. And then 4 goes to 9. So 4, 9. And then 6 goes to 9. So 6 also goes to 9. So we're going to go 6, 9. Don't forget your parentheses. And then 8 goes to 2. So 8, 2. I knew it was going to happen. I was too close to the edge. So pretend that I ended that with the braces, okay, because I don't have room. And there we go. Actually, I kind of do, but I don't want to move over. But anyways, so that's what you should get over there. Notice right here, these are not in order, and I normally like to put them in order. So I would make sure when you make your mappings that you do put these in order. All right. And then so here we created some mappings, right? We have ordered pairs, and so we went the reverse way, right? what if we have the ordered pairs that we want to turn them into mappings, right? So this is literally what you do. You take all your x's, x values. We have 5, 11, 6, 8. I tried to color coordinate them, right? And if you notice right there, that is going to, so we have 5, 6, 8, 11. I wrote them in numerical order. And then on the right-hand side, I did all of my y values. So I got 8, 9, 8, 5. So notice 8 comes out twice, but I'm not going to write 8 twice. I'm just going to write it once, right? And then I'm just going to have 2 arrows pointing to it. Okay, no need to do more work than we need to, right? And so, and plus that's how you do it. And so notice right here, so 5 goes to 8 and also 6 goes to 8. And we can visually see that. And it's a lot harder to see as an ordered pair. It's much easier to see visually in this mapping, right? I like that. And same thing with this guy right here. So on the left, we have the values of 3, 4, and 9, and then 4, 6, 8, 20. Okay, and then going, all the arrows are going to different places. All right, so we kind of, and also here, you guys have already done this before, but if you want to write this as an ordered pair, just remember, so this is just going to be -20, -10, or -10, -20. So literally in that order, you're not changing orders or anything like that. This is just -5, -10, and so on and so forth. Okay, I'm not going to finish that out. All right, so now we have this relation, and we have, okay, remember the first column I told you it was the inputs, what we're putting in, right? And then on the right hand side is the output. That's what we're getting out, right? So if you put in an x, we're going to do some calculations to it, kind of like what we did for the do now. And then what are we going to get out? We're going to get this. So we put in a 2. What are we going to get out? We're going to get a 1. We're going to put in a 3. We get a 5. Okay. I don't know what the rule is here. I'm not going to try and find that out, but this is what it is. All right. And so we've defined a function to be that for every input, you have only one output. Anytime you put in a 1, you get the same number every single time. So I should not be getting, sometimes I get a 1, sometimes I get a 3, like we're not doing that, right? So like I like to think of a vending machine, right? You have a vending machine and you have all these drinks, right? If I put in D7, right? What should I get out? I should always get the same drink of what I'm expecting, right? If I put in D7 to get a, let's see, a Sprite, right? I like Sprite. So if I get a Sprite, and what comes out is like, sometimes I get a Sprite and sometimes get a Dr. Pepper. Then I'm gonna be like, what? It's not working. This thing is broken, right? It's non-functional, right? It's the same idea for a regular function in math, in algebra, right? So if you put in a number, you should always get out the same number. It should not be different, right? You go anywhere else and you do the same math, it should still get you the same answer, okay? It should not matter. All right, so so these two are examples of functions. Example of a non-function. So this is not a function. Notice this, even at one point, it goes to 2 different places. See how it like goes out like this? That is not a function. Okay, so this 2, sometimes you get a 3, sometimes you get a 5. It just depends, right? So that doesn't work. Okay, we can't have 2 different answers, right? So this does not represent a function. Okay, another thing that we need to note on here is I try to put these in order. Oh, my eyes. Is that, where are we? Oh, yes, the domain. So if you look at the domain is the set of all inputs in a function. So what are all the inputs? These are all the x's, right? So domain represents all the x's that you have in that relation, okay? So 1, 2, 3, 4, that's going to be our domain, okay? So I try to put 1, 2, 3, 4 right there. The output is going to be all the y's, right? So that's going to be the range, right? So the range is going to be 1, 3, 5, 7. Okay, it's a very limited kind of function here. Okay, it's very limited. Usually we have more x's and y's than that, right? And then so here we can still have a domain and range, right? So the domain here is 1, 2, 3, 4, 5. The range is 1, 3, 5, 7. But that doesn't mean that it's going to be a function. So any of these relations have domains and ranges, right? It's just that not all of them are functions. Okay. So if you note back here, we went back up here and we're like, okay, which ones are functions, which ones are not a function, right? And so we said, okay, we're going to make this orange color that I don't have right now. So I'm going to make this orange. Come on, orange. Work with me here. Okay, orange. And we have blue. Okay, so orange is a function. So notice each of these arrows, each of these numbers have only one arrow. So this is a function. Okay, this one, each one of these has one number goes to one arrow, right? So again, these are functions. This one right, oh, right here, look at the 2. Even if at one point, one number, it goes to 2 different places, that automatically makes it not a function. Okay, so that is not a function because of that 2, right? Oh, the 2 seems to be the problem here. It doesn't always have to be 2, it just happens to be 2, right? So this 2 goes to 2 different places, so this is not a function. All right, let's see about this one right here. Is this one a function? Yeah, each number goes to one different thing, one different number. You're fine. But you're like, well, what about the 5 and the 6? They both go to 8. You're like, does the 5 only go to one number? And you're like, well, yeah, it goes to the 8. Well, does the 6 only go to one number? Yeah, it just goes to 8. So which means it doesn't matter. It still fits the definition of function, right? So it doesn't matter where they go to, as long as it only goes to that one place. It's very predictable. It's a function, right? This one, 3, oh, 3, through that 3, right? Because of that 3, this is definitely not a function, okay? So this is not a function because of 3, because it goes to 2 different places, all right? And then the question was this, is this a function? Does one input go to one output? It goes to the same output, but yeah, it's still a function, right? So this one is a function as well. Okay, I like to color coordinate it. So you can do what you want on your thing. You can just write function, not a function. That's probably better. All right, and then I'm gonna move on. We kind of talked about all this. So we asked ourselves on 3.2, and I'm on page 211. So we said, okay, so here's some scenarios. So Sue writes a thank you note to her best friend, and her best friend receives the thank you note in the mail. One input, thank you note. One output, yeah, one friend receives it. That's it. It goes to that one friend. Okay, so input, output. So there's a function. Football game is being telecast, right? And it appears on televisions in millions of homes, right? One input. How many outputs? Millions, right? So that's definitely not a function, right? 4 puppies in a litter, right? Okay, so there's 4 puppies. One puppy was adopted by the Smiths, another puppy by the Jacksons, and the remaining 2 by the Fuller. So one puppy, one place. Can you imagine one puppy in 2 different places? That's freaky. Okay, that's a little scary. So yes, that's going to be a function. Even though those 2 puppies went to the same place, remember that was just like 2 numbers going to the same number, right? It was still one puppy, one place, right? Not 2 places. That's, again, freaky, right? Run away. Right, the basketball team has numbered uniforms, right? So they have, 1, 2, 3, 4, whatever the numbers are, right? And each player wears a uniform with her assigned number. One jersey, one person, right? If it was not a function, what would that look like? One jersey, 2 people. Ooh, there better be a big jersey, or 2 very skinny people. That's not good. All right, so yeah, this is a function. And then Beverly Hills, California, 90210. Do you watch that show? I will not judge you on that. I used to watch that show before, like way back in when it first came out, right? It was too much drama though. I was just like, oh, it's just too much drama. Can't handle that. All right, so one zip code, how many people? 34,675 people, right? Live in Beverly Hills. I used to live in okay, I didn't live in Beverly Hills. I lived next to Beverly Hills called Westwood back when I used to go to UCLA. But yeah, that was but definitely this is not a function, right? Because one zip code, many people, right? But I'm thinking maybe your address should be a function, right? Because all the addresses, one address, one home, right? If you have one address and then many homes, okay, I don't know how that works, or one home and many addresses. Okay, I don't know how that works, right? Anyways, so if right here, a sneak preview of a new movie that's being shown in a local theater. So one input, right? How many outputs are there? 65 people are watching that thing, right? So yeah, this is not a function. And we can go on and on, but we won't. We will continue on. I think you get the picture though. But what in your life is a function? You're like, guys, this is not a function. All right, so oh, actually we weren't supposed to get here. We're gonna do this tomorrow. So in your asynchronous time, I'll make a video of this, and then you will watch it and learn it. Okay. I will see you guys later, and make sure you do your homework. And if you don't know where your homework, remember, is in your Canvas page. Scroll to the very bottom, and it's right there. All right. I'll talk to you guys later.